Hi, this is Tim. Welcome to the Math League YouTube channel. Today we're going to be talking about this problem number 23 from Sprint Round 12124. This is the elementary test that was taken between December 2020 and January 2021. So let's take a look at what we have here. An isosceles trapezoid has side lengths as given below. They just want the area, right? So everything we need is in the drawing right now, at least everything we're supposed to take down from the information in the problem. So let's just work with the diagram. We know it's an isosceles trapezoid. Now, one thing to be aware of with an isosceles trapezoid, well, first off, the 25 here and the 25 here, the left and the right sides, those are the two sides that are equal that make it isosceles. The fact that it's a trapezoid means that the 25 at the top and the 39 at the bottom are parallel. Okay, now one of the things that you know to do with geometry problems is draw extra lines. All right. Trapezoids. How much do you know about trapezoids? You probably know something, but do you know as much about trapezoids as you know about right triangles and rectangles? Well, of course not. So let's turn this into a couple of right triangles and rectangles. I'm going to drop an altitude down here and over here as well. Now remember, the way that this works with parallel lines is that these two lines are the same distance apart. So if I'm drawing lines that are perpendicular to the top and the bottom, those two red lines are going to be equal to each other. Now wait, if these red lines are equal, and we've got right angles here at the bottom, and we've got 25 as the hypotenuse for each of these two right triangles, that means that these two triangles on the ends are congruent. Okay, so that's really going to help us out, right? Because I got a 25 at the top. That means I'm going to have a 25 at the bottom. And now we're able to look at this 39 and split it into three different chunks, right? I've got this first part, then I've got a 25, then I've got the rest, and it adds up to 39. Okay, wait a minute. I've already got 25 in the middle. How much is left over? 39 minus 25, that's 14. So I've got 14 between the left and the right side. Again, because the two triangles are congruent, these two numbers have to be the same. Cut the 14 exactly in half, and I get 7 on each side. Okay, I'm going to call the height h for now, and remember that's the same on both of these triangles. And remember we have the Pythagorean theorem, which tells us that 7 squared plus h squared equals 25 squared. Now, this is true of any right triangle, right? The sum of the squares of the legs is the square of the hypotenuse, but hopefully you've got this memorized. There's a few right triangles that show up frequently enough and a few patterns to right triangles that you should be able to look at this and be like, oh, h is 24. If you're not sure, you can go ahead and rewrite it. H squared equals 25 squared minus 7 squared. Now, if you know your squares up to 32, which you should if you're a good number sense competitor, you know that you've got 625 minus 49 equals 576. H equals 24. Another thing you should know is that 25 squared minus 7 squared is the same thing as 25 plus 7 times 25 minus 7. 25 plus 7 is 32. 25 minus 7 is 18. And we have 32 times 18. H is going to be the square root of that. Either way, 32 times 18, of course, is 576 as well. So that'll get you to the same place. 576 is h squared, so h is 24. All right, now once we know that h is 24, let me just write those up here. From here, the area of the trapezoid is pretty straightforward. All right, so remember the area of if you know the formula for the area of a trapezoid, you can just go ahead and plug that in straight away. All right, so you could say that the area is going to equal the average of the two bases, 25 plus 39 over 2 times the height of 24. Well, we can go ahead and finish that out, right? The average of 25 and 39 is 32, and we multiply that times the height of 24. Another thing that you could do is you could imagine taking this triangle on the left and bringing it over and just nestling it right there alongside that 25, kind of rotate it around so that you have a 7 up here and a 25, I'm sorry, a 24 down here. All right, so now what we've got is this triangle has now moved over to here, and what we're left with is a rectangle with 25 plus 7 across the bottom. That's 32, and again, a height of 24. Either way, you get an overall area of 32 times 24, which of course equals 768. And that's how it's done. Hi everybody, this is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.